So data analysis tools. We start with check sheets. Now you may have been using check sheets for the 60-second challenge. That's how it looks there. Or you may be using the 1, 2, 3, 4 slash to get a total of 5. But that's the idea. It's a check sheet. Very straightforward. The next tool on page 24 is a run chart. And with a run chart, you have on the Y or left axis the number of payment errors in this case, and on the X axis on the bottom, you have the total number of days in March. So rather than look at a table full of numbers, by looking at this chart, you see immediately that there are spikes in the number of payment errors every 7 days. What's causing that? Well, immediately you know that you need to look for a cause. The control charts, very similar to the run chart, except we've added upper and lower specification limits as well as a median here. And the control charts are very useful in manufacturing. So we see down here on the bottom the lot number. There are 31 lot numbers, one for each day, presumably. And we can see that on day 11 or lot 11, that the whatever was manufactured exceeded the upper specification limit. So immediately, because we can see that in this graph, we go to lot 11, we take a look at it and see if we need to discard that entire lot of whatever was manufactured. Dropping down to page 25, we have a trend analysis. I'm going to use a slide for this because this graphic is on its side. It's a little difficult to see. Here's the trend analysis. A lot going on here. On the left or Y-axis, we have the number of unemployment cases. And on the X-axis on the bottom, we have a 20-year period broken down into 6-month increments. On the right, we have the unemployment rate. And in gold, we see the number of unemployment cases, and related is the unemployment rate and how those intermingle. In addition, we have 2 milestones, the federal TANF program and California's CalWORKS program added on the left here. So we can see the interplay between these programs and the unemployment rate and the number of unemployment cases. So moving back to the PDF, we have a couple of bar charts I will reshare. So first bar chart has to do with the racial makeup of the state of California over several decades. And the second bar chart has to do with a comparison between high school graduation rates and college graduation rates in California as a whole, the United States as a whole, and in 4 select cities within California. We're going to bypass page 27, go to page 28 for the final chart, which is the Pareto chart. And it is essentially a bar chart. The difference is this line here represents the cumulative percentage. So if traffic plus childcare plus public transportation equals, let's say 77%, we can see that data point right here and kind of guess that it's about 77% of the total of causes for late arrivals. Number 1 being traffic, number 2 childcare, number 3 transportation. And then as we go down the descending order of these bars, we see this line increase to finally reach 100% or 168, which are the total number of late arrivals. So one of the things that's missing in this chart is a very specific reference to the total number of late arrivals due to traffic, for example, and its corresponding percentage. We have to guess. It's roughly 55-ish late arrivals for traffic, and that corresponds to maybe 34%. We don't want to have to guess. So we want, in this case, to put an actual number and its corresponding percentage for each of the bars and to either insert it inside the bar or make some sort of reference to it, perhaps under the word traffic, the label traffic, childcare, etc.